Did you get my email about the exam? Y'all are ready to test?
Say that one more time, please.
When did you do this request? Last night? Okay, yeah. Mondays is super busy for me because I have four classes and I have to do online announcements. So I probably haven't even looked at it yet. But as long as you've never used your extension before, it'll be fine. So you'll get a reply back to me when the extension takes place. Does that make sense? So as soon as it's applied, you'll get a reply back. I just haven't had time to go through all my emails yet. As you can imagine, after due dates, my email's pretty slammed. So just give me like 24 hours to just get do my four classes, check in on my online classes, go through my emails, and then as soon as it's applied, you'll get an email back and let you know when your new due date is. I just there's a button that I would rather because to do one day, if there's a button that just does a week. I would rather just hit that button than go and set a specific date. Okay? Yeah, so you'll just know when it's done. It's pretty cool. Okay, so let's get started. Oh, anyways, sorry about the exam. So your exam is due the 19th. I think I have it. Um, there's a password on it, but I sent you the password. You have 2 hours to do 20 questions. It's over chapters 5 through 7. And so I don't know if y'all know this, but like the way that we formatted it, sometimes it's better to take an in-class test. Does that make sense? Because sometimes when you have the book and stuff with you, which you're allowed to use open book, open note, I feel sometimes you spend more time looking through the book or looking through your notes than actually working out problems. So just be really careful and manage your time because you still only have 2 hours. Okay? I just want to throw that out there. Okay, so let's get started. So now we're on the next unit, and the next unit starts with one section of chapter 9, which is vectors, and they're super fun. They're not horrible. Okay, especially if you're going to go into any kind of physics or engineering, knowing how to apply vectors is beneficial. So here we go. Oh, wait, before we get started, is there any other questions or concerns? If you sent me an email about it, I'll get to it. I just haven't gone through all my emails yet. Okay. You should just send it to me if you don't know what it is, just so we don't sit. Yeah, I just want to make sure we're not go through time. Okay. All right, so here we go. Section 9.1. A vector is used to represent a quantity that has both magnitude, and when I say the word magnitude, we're saying length. Okay, so length of a vector and direction. Examples of vector quantities include velocity, acceleration, force, momentum, etc. Those are all types of vector quantities. A vector in the plane is a directed line segment. The length of the vector represents the magnitude, like I have here, and the angle represents the direction. So length goes with magnitude, angle goes with direction. Two vectors are equal if they have equal magnitude and the same direction. It's like the same thing over and over. So magnitude just means length and then direction. Once you have vectors, you can do different things with them. Like you can do add vectors together. So addition, subtraction, scalar multiplication, dot product, cross product, which you'll learn if you take Cal 1, Cal 2. But we're just going to start with basic stuff like adding, subtracting, and scalar multiplication. That's why that's bolded, because that's what we do in this class. But there are different things that you can do with vectors. The first thing that we're going to talk about is addition of vectors. There's actually two ways to do it. There's the head to tail method. So if you look at that, here's the tail of one vector. And then notice how, can y'all hear my son, or is that just me? Oh, it's not cute. Drayson! Tell Vea to come down and help you. Okay, so here's U, here's V, okay, and this is U plus V. So if you match the head and tail of two vectors, then the tail to head is the addition. So that's one way to do it. Maybe I should do this in different colors. Another way to do it is if you have two vectors that are tail to tail. So here's one vector. Here's another vector. So notice how this is tail to tail. Be very careful. If it's tail to tail, then you cannot connect the heads together. Does that make sense? You can't put these together. They have to be head to tail in order for you to do it this way. So if you have two vectors that are tail to tail, what you have to do is come over here and make a corresponding parallelogram. So this is the same length as this side. Where's my purple? This is the same length as this side, and then you're going to do, this would be U plus V. Or, yeah, this is V. This is U. Does that make sense? And so that'll show you the direction and the length of your new vector. Okay? Multiplication of a vector, if you check that out, it's pretty self-explanatory. If you have V, here's V, and you want half of V, then it would be half the size, still going in the same direction. If you have 2V, it would be double the size of V. Negative V, having a negative V, same size as V, just in the opposite direction. So when you have a negative value, it just flips the direction. Is everybody okay with that, with the geometric description of vectors?
Yeah,
Any
that's
questions?
pretty simple.
Yeah, it's not bad. Okay, so if you look at the first example, it has two vectors, right? Here's the vector, and here's the vector. Make sure that delta. You look at yours, don't look at mine. Okay, here we go. No, no. These are, even though these arrows they're indicating direction, not that they go on forever. Is everybody okay with that? These don't go on forever. They have a specific length. Is that cool? But the arrow is there to indicate the direction that it's going in. Does that make sense? Okay, so if you have these two vectors, here's U and here's V. Here's another coordinate plane over here for you, and I want you to draw V minus 2U. I want you to draw V minus 2U. So as you notice, V did not change. So V, I want you to come over here and draw V, is going to stay exactly the same. So if you notice, that's at 0, 0, and where is that end at? It looks like 3, 4. Make sure this is at 3, 4, and draw a dot. Is everybody okay with that?
Yes, ma'am.
Okay. Now, this is negative 2U. So then do you agree that this is going to double in size? That U is going to double in size,
Yes,
right? And then what direction is it going to go in?
it's going to go in quadrant 4.
It is. Okay. So I want you to notice that this is 2 units this way, and it looks like 3 units up. Do we agree with that? So I'm going to go 4 units this way and 6 units down. Do we agree with that? Ooh. So this is negative 2u, and this is v. Are we okay? Any questions? Okay. And then how would we find the resultant vector? How would we find the vector that's the answer? Any questions? Are we okay? Okay. Could I just go from here to here? Is the answer from, don't draw this, is the answer from here to here? Is that the answer?
No,
Why?
because it's a parallelogram.
Yes,
Right?
it has to be done parallelogram method. Now, how do you know that?
Because it's tail to tail.
Because it's tail to tail. Does that make sense? So because of that, I need to come over here and I'm going to draw the parallelogram. So this is the same length as that one. This one's the same length as V. And so then your answer goes from here to there. This is the opposite side. Is that what you mean? This is the same length as this. This is the same length as that.
So,
It's a parallelogram because I can't confirm what the angles are.
so the
I can't
opposite.
confirm the angles are 90 degrees. So the opposite sides are equal to each other.
So the opposite side, you would draw. You would start from D, and then you would move over 4 to the right and down 6 again to get your point, just like you
Exactly.
did from the 0 to 0 plane.
Yeah. And then you go from tail to the other, and you draw a diagonal through your parallelogram, starting at the tail of the same tail as everybody else, and then go to the opposite side. So this purple one would be your answer. Does that make sense? Yes, no, maybe?
Yeah, that makes sense.
Okay. So it's really important that, like, if they give you something, they say, okay, this is you, and this is V. And first it says I want you to do U plus 1 or minus. Maybe I should do minus. I want you to do U minus 1/2 V. That makes sense? Something like that. Well, then you would have to come over here and draw each vector separately. U did not change. So then you would just come over here and you would draw U. Same U. I don't, maybe I'm not understanding the question. We're not, my question is where you get that we are measuring. It says, in the example, it says sketch the vector. So we're not measuring anything. We're just sketching the new vector. Right? Like if I said, hey, this is you, what does half of you look like? I'm not really measuring it. I'm just sketching what the new vector would look like. So back, like if I were still continuing on with this example, this is a vector. U is a vector, V is a vector. This right here is also, it's one vector. And I want you to sketch what that vector looks like based off of the two vectors that I gave you. So you would have U, And then V is half, but on the other side. So do you agree that's V? And since they're tail to tail, I would have to come over here and sketch a parallelogram. So there's the other side of V. Here's the other side of U. And then for your new picture, you would start here and you would go towards the other. And that right there, that is U minus 1/2 V. That would be the sketch of it. So like if you're done with this, if you go to your homework, the very first few, you're not measuring anything. They're literally going to give you this, the original picture, and they're going to give you 4 multiple choice ones to come up with the new picture. And that's it. Okay. All right. So then the next thing that we're going to do is this is how you look at it geometrically. But what if I want to do something called component form, okay, of vectors? And so what happens is if you give me what a component form does, you guys, is it kind of moves it to start from 0, 0. So like, let's say that you had the point -1, 3, and Q is -6, -1. Does everybody see where I am? If you were to plot this, -1, 1, 2, 3, there's P. And then Q would be -6, -1, -6, -1 down here. And that would be Q. And this would be your picture. P to Q. Does that make sense? If I were to move this bad boy so that this right here was at the origin, where would this point be? Does that make sense? I'm not stretching it. I'm not doing anything like that. I'm just moving it. And so I'm moving it so that this point right here could be at the origin. Where would this point be? And so that's getting your vector in component form. Now, all you have to do is you subtract -6 minus a -1, comma, -1 minus 3. You subtract corresponding positions. So like if this was x1 and this is y1 and this is x2 and this is y2, all you do is x2 minus x1 still goes in the x position, and then y2 minus y1, and that goes in the y position. So wouldn't my answer be -5, -4? Yes, it's because it's the second point. So the first point is your initial point, and the second point is your terminal. Is that okay? So far, so good? Oh, and it said that in the problem. Express the vector with the initial point P and the terminal point Q. So if you were to move this here in the same direction, this point would be -5, -4. Pretend those are the same length. Okay, so you try B. Okay. What'd you get for B? Anybody get anything for B?
7-3.
Yeah. Did everybody get 7-3 for B?
Yes, ma'am.
Okay, and so like you said, 7, 3 just means now the tail end is at 0, 0, right?
Yep.
So 0, 0, now the head end is at 7, 3 instead of where P and Q is. It
Yeah.
just shifted.
Yes, it just shifted. So
Okay.
if P is at -8, -6, and Q is at -1, -3, you should have done -3 minus a -6, comma, -1 minus a -8, right? And if you draw those, all you're doing, is you're taking that P and putting it here. And then you're telling me where is your Q going to end up. Does that make sense? And that would be at 7, 3. I'm on the wrong thing, aren't I?
Oh, okay. So this is
I messed up. Okay, I was on the wrong. It's okay. Shh, I was on the wrong thing. Sorry. Hold on. It should have been -1 minus -8, and then -3 minus a -6. I was on the wrong thing. Sorry. But 7, 3. Is that okay?
so
now, is there any questions?
P is just 1 point, Q is just 1 point. So really, P and Q just make up one vector. It's not.
Yes, that is correct.
Okay.
P and
Okay,
Q only make up one vector. It tells you your starting point, it tells you your end point, and then you're giving me that same vector, but in component form, meaning you moved the P to 0, 0.
Okay, yeah, that's too easy. I'm just making sense of it in my own head. Thank you.
It's okay. Anybody else? Any questions? Oh, that's what component form does. It'll always start at 0. It'll make your application problems later on easier if you start at 0, 0. Like, like even when you do how like when we talked about the unit circle, we said we're always starting on this side and then you start from there. Well, usually when you're working with vectors, you always want to start at the origin. But I can draw a vector anywhere I want to. I can draw a vector there, here. You can draw a vector anywhere. So what component form does is it takes the vector that you create or what they give you and automatically puts it at 0, 0. Does that make sense? What exactly? Whatever your component form is. We okay? Moving on. Okay. So then once you have that, you can just do basic things. We talked about like, okay, here's U, then this is 2U because it is that in it's just doubling the form. Does that make sense? It's just doubling the vector in size. So what if you don't have a vector to look at? What if you just have it in component form? Well, then you just do the math. So for example, let's say that U is equal to -2, 5. I'm on the next example. And V is equal to 2, 8. As you can see, these are in component form. You know they're in component form because you see these little bracket symbols. That means they're in component form. So the first thing it wants me to do is it wants me to find 2U. So it wants me to double 2U. So then the answer would just be -410. It is that easy. You're just distributing the 2. That's it. B is -3V. So that's going to be -6, -18. Is everybody okay? U plus 2V, you do the work to the corresponding positions. So U would be -2 plus 4. Does it make sense? -2 plus 4, which would give you? Right? And this one would be, what would this one be? 5 plus 16? Oh gosh. What's 5 plus 16? 21?
Blackjack, baby.
Yeah, and that's it. That would be the answer. Does that make sense? And then let's do D. What does D want? 3U minus 4V. So 3U minus 4V You try that one and tell me where it is. I really don't know. I didn't do this one. Anybody got it? Is that right? I don't know. I didn't do it. What is -6, right? Minus 8? -14? Is that what you said? I'm sorry? The 5 and the I'm not. Oh, maybe. Yeah, maybe. Sorry. Hold
Yeah,
on.
she's right.
I'm sorry. Let me do that. I have to do it out. Okay. So it would be 3 times -2, which is -6, right? Minus 4 times v, which is just +2, right? Am I wrong?
Yes, ma'am. That's what I got.
It's -6 minus 8, which is -14. And then 3u. What is that? 3 times 5 minus 4 times 8? I don't know. What is 15 minus 32? -17? Is it -17? Okay. Are we okay now? Let me try to do mental math. Okay. So that's how you would do those. Basically, you just do basic arithmetic with these problems to get vectors. A vector of length 1 is called a unit vector. Okay, a length 1 is called a unit vector. Okay, you can also, remember this is called component form. With these brackets, that's component form. You can also express vectors in terms of I and j. So this is your I axis. This is your j axis. So I and j. So look at that, you're learning new axes. These are the vector axes. And so it's the same thing. Like if you have, let me go back up. If this right here is -2, 5 in component form, u would equal -2i plus 5j. This would be in ij form, the vector in terms of I and j. That's it. So the I value goes with the horizontal number and the j value goes with the vertical number. Okay? So if you look at the example 4, it says that u is equal to 2i plus j, and v is equal to 3i minus 2j. It's just another way to express vectors. So again, it's asking you for 2u. So 2u would be 4i plus 2j. Negative 3v would be negative 9i plus 6j, right? And then u plus 2v would equal, oh my gosh, u plus 2v. So that's 2 plus 8i, right? And then, is it negative 3? Three u minus 4v. This is getting complicated without my calculator. 3u minus 4v. Negative 6i. 3u minus 4v. 11? Okay. Did y'all get what I got? Okay.
Yes, ma'am. That is what I got.
Okay. I'm going to scroll up just a tad. Okay. The next thing that we're going to start talking about is the magnitude of vectors. Magnitude is the length of the vector. Okay. So it's how long the vector is. To find the magnitude, now different books have different things. I hate that this book uses this symbol because to me that's absolute value. You'll see some books do this, which I like better, meaning magnitude. But either way, if we're talking about vectors, to find the magnitude of the vector, all you do is you take the square root of your x squared plus your y squared, or your x component squared plus your y component squared. And let me just talk about why this is. Because if you put a vector in component form, you don't have to write this down, I'm just explaining something. If you put a vector in component form, and let's say that it's from here to here, here's the vector, right? And let's say that this right here was the 0.34. Doesn't that mean that it's 3 units this way? 3 units? Doesn't that mean that it's 4 units up?
Yes.
Make sense? So then how would I find the length of that vector?
Pythagorean theorem.
Pythagorean theorem. So you would do 3 squared plus 4 squared, and then you would take the square root of it. So that's all that's saying. That it's going to put it in component form, and then all you're doing is finding the length of that vector. So if you look over here, they have them in component form. They're just putting it in ij format. So you have negative 2i plus 3j, and v is I minus 2j. And the first thing it wants to know is what is the magnitude of u? So just of u. So I would have the square root of 4 plus 9. Do you agree with that? Which is the square root of 13. So the magnitude of u, the length of u's vector, would be the square root of 13 units. Is that okay? The magnitude of v's vector would be 1 plus, what about the square root of 5? You got to square the coefficient. I'm sorry? True that. What happens when you square numbers? But you're using this formula, so you have to square both of them, right? Sure, when you square any number, it's always positive. Now, before you can do the vector of 2u, before you can find the magnitude of it, I actually have to know what 2u is. So then do you agree that 2u would equal 4i, line negative 4, negative 4i plus 6j. So you actually have to find, we knew what u was, it was given. We knew what v was, it was given. We didn't know what 2u was, like that vector was not given. But we just practiced finding that. So 2u would be negative 4i plus 6j. And so now I can come over here and find it. You're going to ask me a question here in just a second. I just want to go through the steps. So then you would have the square root of, what is that, 16 plus 36? Do we agree with that?
Yes, ma'am.
Ugh, what is that?
52.
Okay. And does the square root of 52 come out pretty? I mean, can we simplify that? I guess not, huh? Or can we? Yeah? Anybody? Isn't that 2 the square root of 13? We agree?
Yes, ma'am.
Now, if u is the square root of 13, wouldn't 2u be 2 times that length?
Dang.
Makes sense? Like you're doubling it in size, right? So you didn't even have to come over here and find 2u. You already had u. So you could just double it in length. I just want to show you practice finding magnitude. So what about u minus v? Now this one I can't do. I don't think I can do a triple file one. I don't know. So u minus v, we're trying to find the magnitude of that. But first, I'm going to find out what u minus v is. So wouldn't u minus v be negative 3i plus j? 5j? My thing. Okay. Yes. So 5j. That's okay? Okay, and so then come over here. Right? Oh, what is that? The square root of 34? Is that what you're about? I think that's it, right? I don't think you can simplify that. Can you?
I don't think so.
Yeah. Okay, then that's the answer. Is that okay? Okay. Then the next one says take the magnitude of u minus the magnitude of v. So then it just wants you to subtract. So it's different. U minus v is an entirely new vector. U minus v is an entirely new vector, right? So what we're doing is coming over here and actually just taking u the way that it was and taking that magnitude and subtracting v's magnitude, which is the square root of 5. And since these are not the same, that's it. You can't simplify that in any other way. Okay. So now we've talked about the length of the vector, so combining vectors, component form, ij form. So we really just kind of stuck with the length of the vectors and the location of them. And so now we're going to actually talk about the angle of the vectors. So if you look at the next page, okay, and it says you have this vector that is a1 comma a2. This is in component form, or I can write this as, excuse me, a1i plus a2j. That would be ij form, okay? A1 is equal to the magnitude of that vector times cosine of theta, which makes sense. Cosine is your horizontal component, right? So this would be the horizontal component. Where A2, the J1, is equal to the magnitude of the vector times sine of theta, which is your vertical component. Okay, so then the vector can be expressed as the magnitude of E cosine theta I plus the magnitude of E times sine theta J. We can express it this way. So it's another way they express in terms of cosine and sine. Now, something that you might like is that when you're dealing with vectors, you kind of usually go back to degrees. So the standard form for vectors, the angles are in degrees, which is cool. Okay. So if you look at the example says, I want you to find the horizontal and vertical components of the vector with a length of 50. So the magnitude is 50, they told you. And your angle is 225 degrees. And it wants you to write the vector in terms of I and J. Okay. So they're telling you that the magnitude of V is 50. And they're telling you that theta is equal to 225 degrees. So if they want me to write it in terms of A and J, I and J, wouldn't that be V equals, here's my vector, 50 cosine of 225 degrees, I, plus 50 sine of 225 degrees, J. All I did was substitute it in right now. I haven't done anything else. I'm about to, but I haven't. We okay? So then I'm going to come over here and I'm going to say, okay, that's equal to 50. What's cosine of 225? Third quadrant? Negative square root of 2 over 2? I? And there you go. And that would be your vector. $50 divided by 2 is 25. $50 divided by 2 is 25. Anybody else have any questions? Are we okay with these? Angle things. What angle things? Oh, you are bringing up an excellent question. You are either in component form or IJ form. You can't be both at the same time. Does that make sense? So the little angle thingies are when you're in component form or only. Don't do both at the same time because it's going to count it wrong. Okay? So this specifically asks for IJ form, so I'm not going to put the things. Is that cool? Also, when you do, if let's say that it did ask for component form, like if the next part of the question said component, then you would do this and you would say negative 25, the square root of 2, comma, negative 25, the square root of 2. I'm trying to write too small. My pen's like, what are you doing? You don't put the I and the J because you're in component form. Does that make sense? You okay with those? Okay, moving right along. The next one says, I want you to find the magnitude and the direction of the vector, and it gives you the component form of negative 12, comma 5. So this is component form. Do you agree with that? So I'm just going to take myself a little coffee break. I actually need to make some more coffee. And I want you to tell me what the magnitude of this vector is. So first we're going to find the magnitude because it wants me to find the magnitude and the direction. So let's find the magnitude first. Okay, anybody got the magnitude? Are we okay?
13?
Yeah, 13. All right. Are we okay with the I don't know. They didn't give us a name. Let's call this V. Is everybody okay that the magnitude of V is 13? Okay, we're going to talk about direction. We okay with direction? Okay. Okay, I want to spend some time on direction because if it's asking for direction, it's asking you for theta, right? So it wants to know what theta is. So do you agree that A equals your horizontal component? So let's say that this is A and this is B, okay? So A equals the magnitude of your vector times cosine of theta, okay? If you go back up to the very top of this page, it tells you that your horizontal component, your A1, is equal to the magnitude of V times cosine of theta. Well, you know what your horizontal component is. Your horizontal component is negative 12. You also know what V is. V is 13. Couldn't you solve for theta? This make sense? Yes, no, maybe? So make sure you're in degree mode, but you would have cosine of theta equals negative 12 over 13. Make sure you're in degree mode. Theta equals cosine inverse of negative 12 over 13. Let me know what you get.
I got 157.38014 degrees.
Okay. Let's just go to 2.
There.
No, I mean, you're right. I just didn't want to write all that. Is everybody okay? Is everybody cool with 157.38? Okay. So the point is, where did I write these down? Right here. The point is, you could take either one of these. You could take the horizontal component, you could take the vertical component, and all you're doing is solving for theta. However, now that I've said this, I'm going to spend some more time on this one. What if I had chosen the other one? What if I didn't want to use my horizontal component? What if I had wanted to use my vertical component instead? How would I have set that up?
The same way, just with sine and the y coordinate.
So wouldn't you have 5 equals 13 sine of theta? Do you agree with that? And that would give you sine of theta equals 5 over 13, which means theta equals sine inverse of 5 over 13. Can someone put that in their calculator for me?
Get 22.62.
22.62. Now that's odd. Which one's the answer? If you should be able to do it with either one of them, because it's vertical and horizontal component, then which one am I going to stick in what assign? Which one's the right answer?
I don't know. Maybe add them?
Nope,
no.
It's one or the other.
Because that's 180.
Anybody have any ideas?
The bigger one.
Yes. But why?
Because it's the head to tail method. So your magnitude is actually starting from the horizontal plane. I don't know.
Usually, if we had the time, I would let you think about it, but we don't have any more time. So it's the bigger one. In this case, it's not always the bigger one. It's in this case, it's the bigger one. Where is this point located? If this is component form, that means I'm starting here. Where do I end?
Negative 12.5.
Which quadrant is negative 12.5 in?
2.
It's in quadrant 2. So what is the length from here to here is 157.38. So it's 157. Well, kinda. So quadrant, if this point is in quadrant 2, right? You have the right idea, Melissa. This point is in quadrant 2. Didn't you just use sine inverse in your calculator? Does sine inverse know how to look in quadrant 2? What are the only quadrants that sine inverse will look in? 1 and 4. So this right here is 22.62 degrees. It's only looking in quadrant 1. So then if you did symmetric wise, isn't this also 22.62? Right? So then my question to you is, what is the angle from here to here? Wouldn't you do 180 minus 22.62 degrees? Someone do that in their calculator. What is 180 minus 22.62? Same answer. Same answer. You're in the wrong quadrant. If you do sine inverse of 5 over 13, it gave it to you in the first quadrant because your calculator only knows how to look in quadrant 1 and quadrant 4 when you put sine inverse in. So you have to remember what quadrant you're in. You're in quadrant 2. This point is in quadrant 2. Make sense? So then you have to fix it. So if that reference angle is 22.62, then so is this one. And then you find the angle from here to here, the purple angle. And so that's how we get 157.38. You want to remember that because it depends. I can make it hard depending on which quadrant I'm putting my terminal side in. Okay, one more. Let's see if we can squeeze one more in because it's an application problem. Okay. So it says, I don't know what it says. A migrating salmon heads in the salmon? Are we talking about fish? Heads in the direction north 45 east, swimming at 5 miles per hour. So insert. I might not get this. I might have to just draw the picture. Let you think about it. Okay, so I'm going to come over here and draw this loveliness. And it says from here, we're going this way. North, never eat soggy waffles. North 45 degrees. We've already talked about bearing. So this right here is 45 degrees. We agree with that? And we are going 5 miles per hour. Then it says, a migrating salmon swimming at 5 miles per hour relative to the water. The prevailing ocean currents flow due east. So the ocean current is going this way, due east. Do we agree with that? At 3 miles per hour. Find the true velocity of this fish vector. So it wants me to find, even though the fish is trying to swim on this path, if the ocean is trying to push you this way, aren't you going to be pushed? Does that make sense? Has anybody tried to ever swim across a river and you swear you're swimming straight? Does that make sense? But what's really happening? You are. Even though you think you're going straight, you're swimming straight. The current is pushing you. Does that make sense? So isn't this asking us to add these vectors together? Does that make sense? Mm-hmm. Yes. I didn't label them, did I? Really well. Okay. And since they're tail to tail right now, right? Aren't I going to come over here and do this loveliness? Pretend that's straight. And this would be my answer. Oh, I need like a ruler. This would be my answer. Does it make sense? Okay. So I'm going to do the velocity of the fish. I know angle. I know my magnitude. Velocity is magnitude. We're talking about velocity vectors. So wouldn't that be 5 cosine of 45 degrees plus 5 sine of 45 degrees? This is your J component, and this is your I component. We're only talking about the fish. Let me get a different color while you're writing that down. We're only talking about this vector, right? We know the angle, which is 45 degrees, and we know the magnitude, which is 5. Okay. I'm going to clean this up just a tad because I know what cosine of 45 degrees is. So this becomes 5 the square root of 2 I plus 5 the square root of 2 over 2 J. And now I want to talk specifically about the current of the ocean or whatever we're talking about, river. Okay. So if we talk about that, you guys, can anybody tell me what that vector is? Does that vector have a vertical component?
No.
Even if you talked about angles, what angle would that be?
0.
Yeah, it would be the angle of 0. So even if you set it up like this, like I'm going to do the vector of the water, and it's going to be 3 cosine of 0 degrees I plus 3 sine of 0 degrees J. What is sine of 0? What is cosine of 0? So wouldn't you just get 3i? Yes, no, maybe? Which makes sense. There was no vertical component. There was only a horizontal component. It's not going diagonal. And so now that I have the vector for my fish and I have the vector for my water, and I want to put them together because they do have an effect on one another, don't I just add these vectors together? So my final answer of my fish plus my water would equal 5 the square root of 2 over 2 plus 3i plus 5 the square root of 2 over 2j. I don't know how to add those together, so I'm going to leave it exact. And this right here would be the true velocity of the fish. It would be the fish with the current acting upon it. And that's where I will leave you for today. Okay. We're good? All right, then I will see y'all tomorrow. Have a good day.
Thank you. You too.